Okay, 4.8. This is the last section of Chapter 4. Couple of vocab terms to start. Transformation. A transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. And there are different kinds of transformations that we'll be looking at, namely these three: translation, reflection, and rotation. An image, the new figure produced by a transformation, is the image. So when we perform these transformations, and we'll do some examples of what these transformations look like, the new figure that you get as a result is called an image. So anytime I'm talking about the quote-unquote image, that's what I'm referring to. Okay, I'm going to do all three of these at once. Alright, I know I added a lot of information here. I'm going to take some time to talk about it. If you'd like, you can go ahead and pause and copy all this stuff down, and then hit play again. A translation moves every point from a figure the same distance in the same direction. So for example, over here, if this was the original figure and I just moved it over here, that's a translation. You just shift it. It doesn't have to be this way. It could be this way, up, down, diagonally, whichever way. A reflection uses a line of reflection to create a mirror image of the original figure. So over here, this is the line of reflection that I used. It doesn't have to be this way. You could have a vertical line of reflection or a diagonal line of reflection, and basically I just flipped it over. So if you imagine looking into a pond or looking into a mirror, this is the reflected image that you're going to see. And once again, doesn't have to be this way. You could reflect it this way. You could reflect it diagonally. Rotation. Alright, this is actually the one I had the most difficulty drawing. That looks kind of off, but I did my best. A rotation turns a figure about a fixed point, called the center of rotation. Basically, it just took the figure and it rotated. Okay? This one, probably this tip should be a little bit farther this way if it was a true rotation, but that's essentially what a rotation is. Okay? A congruence transformation. A congruence transformation changes the position of a figure without changing its size or shape. Okay, so basically, all three of these are congruence transformations. Even though I move or reflect or rotate a given figure, its image is congruent to the original figure. This is congruent to this. This is congruent to this. These two triangles are congruent. I moved it, but I didn't change its size or its shape. Okay, that's a congruence transformation. Okay, example 1. Name the type of transformation demonstrated in each picture. This one, you can kind of tell, is a rotation about a point. This one is a translation in a straight path. And this one is a reflection in a vertical line. Alright, let's go on to page 2. Coordinate notation for translation. Okay, this is kind of important. You can describe a translation by this notation. Basically, if you are given a certain set of points, and you add, or you could even subtract certain numbers from those points, that represents a particular translation. I'm going to do an example of what this means, but hopefully you can tell that if I were to add a certain number to all the x coordinates, this whole thing would move over here. If I were to add a certain number to all the y coordinates, it would move up. Okay? Or if I were to subtract, it would move down and over. So for example, figure ABCD has vertices A, 1, 2, B, 3, 3, C, 4, negative 1, and D, 1, negative 2. I'm going to sketch this. Here's A. Here's B. 4, negative 1. Here's C. 1, negative 2. And here's D. Okay? Imagine those lines are straight. Okay, first draw A, B, C, D, we did that. Find the translation of each vertex by let's see here. Oh, we're subtracting 4. By subtracting 4 from its x-coordinate and adding 2 to its y-coordinate. So every x value, I'm going to subtract 4. Every y value, I'm going to add 2. So if I have 1, 2, 1 minus 4, I'm going to call this A prime. 1 minus 4 is negative 3. 2 plus 2 is 4. I'll call this B prime. 3 minus 4 is negative 1. 3 plus 2 is 5. C prime. 4 minus 4 is 0. Negative 1 plus 2 is 1. D prime. 1 minus 4 is negative 3. Negative 2 plus 2 is 0. And I'm going to change colors for this next one. A prime is at negative 3, 4. B prime is at negative 1, 5. C prime is at 0, 1. D prime is at negative 3, 0. And if you do this right, you should get 2 congruent figures. Okay? Excuse me, sorry. Okay. Coordinate notation for reflection. Reflection in the x-axis, basically, you multiply the y-coordinate by negative 1. Reflection in the y-axis, multiply the x-coordinate by negative 1. Alright, let's go on to page 3. You are cutting figures out of paper. Use a reflection in the x-axis to draw the other half of the figure. Okay, so this is what we're given. We're going to multiply the y-coordinate of each vertex by negative 1 to find the corresponding vertex in the image. Okay, so if we're given this, and I want to know what it looks like down here, just take each y-coordinate and make it negative. So the first one, 0, is just going to remain 0. 1 becomes negative 1. 4 becomes negative 4. Negative 1. And 0 remains 0. Let's graph each of these points. Negative 1, 0. 1, negative 1. 2, negative 4. 3, negative 1. And 7, 0. So it should look like this. And if you do it right, it should be a mirror image. Okay? You can check your results by looking to see if each original point and its image are the same distance from the x-axis. One very common mistake, sometimes if you accidentally miscount and you draw your point here, you'll end up with a short arm. But at the end of it, you can look and go, oh, that doesn't really look right. And fix whatever didn't work. Okay? Alright, I'll let you guys do the checkpoint. Let's go on to page 4. Graph JK and LM. Tell whether LM is a rotation of JK about the origin. If so, give the angle and direction of the rotation. Okay, so first thing, let's graph this. J is 3, 1. K is 1, 4. L is negative 1, 3. And M is negative 4, 1. Okay, so JK is here, LM here. Alright, so if you look, you can kind of tell just because this is 3 and this is 2, this is 3 and this is 2, that these angles are going to be equal. Let's see here. If this is O, JOL equals the measure of angle KOM. Let me use different colors for this. This angle is equal to this angle. And you can kind of tell this because the triangles are congruent. Okay? Now, you can also hopefully tell this is a right angle, as is this one. So the angles equal 90 degrees. So this is A. I'm going to switch back to blue. 90 degrees counterclockwise rotation. Alright, let's do the next one. J is -2, 1. K is -1, 5. It's here. L is 1, 1. And M is 2, 5. This is an L. Doesn't really look like it. So here's my first line. Here's my second segment, actually. It's not really a line. Okay. If you were to measure these, here's the origin again. JOL, this angle, does not equal this angle. It's actually very obvious that this obtuse angle does not equal this acute angle. Okay, so this JOL is actually much bigger than KOM. Switch back to blue. So this is not a rotation. Now, I know most of you guys do not have protractors at home, so if I give you problems like this in a checkpoint, it's going to be obvious. If it's not obvious, just make your best guess. I'm not going to grade you on that one, okay? It's going to be very obvious whether or not they're congruent. And if it looks like a right angle, it probably is a right angle. Okay? Alright, last page. The vertices of triangle PQR are these. I will go ahead and draw this triangle. So here's the triangle we're given. We are also given a translation for this triangle. So if I were to add 1 to each of the x's, get 3, 4, and 6, and if I were to subtract 6 from each of the y's, I would get -4, -2, -4. Alright, I'm going to pause again and graph the translation of this figure. Alright, so here is our new figure. You can see that PR is the same distance as XZ. Yep. And that equals 3. So PR is congruent to XZ. Also, using the slopes, you can tell that PQ is parallel to XY. And QR is parallel to YZ. If you extend PQ and XZ to form angle V, then the corresponding